So now we've talked about what happens when you add water, for example, to the body, or sodium to the body, or any combination of those things. We talked about isotonic fluid, hypotonic fluid, hypertonic fluid. And we talked about what happens in terms of pure chemistry or physics, what happens to the solutes and to the water, and how those things shift around. And we saw that basically different combinations of salt and water can cause different changes in volume and different changes in concentration of the body's fluids. But now we're ready to take this to the next step, and that is, how does the body now react to these changes? And this reaction right here is really the job of the kidneys. So now we're really getting to the crux of renal physiology, which is how does the body regulate salt and water balance? And we've been promising that we'd get to this for a long time, and we finally are there. The first step to understanding how the kidneys react is to understand that there's two different things that they can react to. The first is right here. It's a change in volume. So if there's a change in volume, the kidney can measure that, and then it can react to undo that. And it's important to specify that when we say volume, we mean specifically extracellular volume. Now, why is it extracellular and not intracellular? That's a loaded question that we'll get to later. For now, just remember, what the kidney is measuring is extracellular volume. And the other thing the kidney can react to, the other thing it can measure, is concentration. So precisely the other thing that we mentioned here. Now, not only does the kidney measure these two different things, but it also reacts differently to each one, because a change in volume is different from a change in concentration. You can think of ways that you could change the volume without changing the concentration, or ways that you could change the concentration without changing the volume. So for example, if I give you a bunch of isotonic fluid, that's going to increase your extracellular volume, if you remember, but it's not going to do anything to concentration. So the kidney really has two different programs to react to these things. It has one to correct the volume problem, and then it has another program to correct the concentration problem. And right now, this is probably all sounding really abstract and confusing, but just remember that the kidney has these two different programs. One responds to and tries to correct changes in volume, and the other responds to and tries to correct changes in concentration. So we talked about the fact that the kidney has these two arms, the one that responds to volume and the one that responds to concentration. So now I want to ask you a question, which is, which one do you think is more important? Which one of these does the kidney need to respond to more quickly and more sensitively? The answer is concentration. And there are a couple of reasons why you might think that would be the case, and I'll give one argument. And that is that the body is basically just a combination of many, many different chemical reactions. Those reactions include metabolic reactions, reactions to make protein, reaction to make DNA. And what matters for reactions is not how much volume you have, but what concentration of stuff you have. So if you're a chemist in a chemistry lab, it doesn't matter how big your flask is. It doesn't matter if you have a big one or a little one. What matters is that the concentration of stuff in the flask is at the appropriate level. So that's a kind of argument for why concentration is more important. And you can see that the body cares more about concentration because we can actually notice that the kidney reacts to very, very tiny changes in concentration, but only to larger changes in volume. So actually something as little as a 1% change in your sodium concentration in your blood can cause a noticeable reaction by the kidney. Whereas a 1% change in your volume, in your extracellular volume, would not cause that change. You might think, for example, about a wrestler or a boxer who is preparing to make weight. A lot of times they'll try to lose water volume, as they call it. And what that means is they're losing extracellular volume. So before the weigh-in, you might see their volume go down so that their weight decreases and they're okay. But if you were to look at their sodium concentration during that time, what you'd find is that it's actually remarkably constant. And that's because the body is very careful to regulate concentration, but less careful to regulate extracellular volume. So throughout your life, over the months, over the weeks, your volume can change, your water weight can go up and down, but the actual concentration of sodium in your blood barely changes from day to day, from week to week. We've established that the body reacts more quickly to concentration changes than to volume changes. But now let's talk about how it reacts. So let's say that your concentration of sodium ions went up. So I'm going to draw in a bunch more sodium ions here. What are the kidneys going to do to bring that concentration back down? If I asked you to come up with the most obvious response to that question, I think what you'd probably say is, well, the kidney is just going to try to get rid of some of those sodium ions. And that would work. That would be one possibility. But there's actually another possibility, which would also work, and that is that the kidney could add in some water. Because if you add in some water, it's going to decrease the concentration of all these solutes. So these are two different approaches, and theoretically the body could use one or both, but it turns out that actually it uses this somewhat less intuitive one. It actually adds in more water rather than getting rid of sodium ions. So what's the result of this? Well, we start with an increase in sodium. That would cause an increase in sodium concentration. And that causes the kidney to increase the amount of water in your body. And in just a second, we'll talk about how it does that. And water obviously takes up volume. So together, these things are going to cause an increase in extracellular volume. And you could also imagine the opposite situation where you have, for some reason, a decrease in the amount of sodium in your extracellular space. And the way the kidney is going to correct that is not to add sodium, but to get rid of water. That'll bring the concentration back up. And so that, of course, will decrease your extracellular volume. So you can really almost think of this as a paradox because it's very confusing and it's easy to forget. The paradox is to monitor and to change sodium concentration, your body doesn't actually add or remove sodium ions. It adds or removes water. And how does the body change the amount of water here in response to the sodium concentration? Well, there's actually two main ways that it does that. The first way is thirst. If you have an increase in sodium concentration, you're going to become more thirsty, so you're going to go find a glass of water and drink it. And that's going to increase the amount of water. And the second has more to do with kidneys. The second is changes in water excretion. And the idea there is an increase in sodium concentration is going to cause you to excrete less water. So you're going to hang on to more water, so you're going to get more water in your extracellular space. Whereas a decrease in sodium concentration means you want to decrease your amount of water, so you're going to excrete more. So you're going to urinate out more water. So these two mechanisms affect how much water is in the body, and so they affect what we call water balance. And once again, I want to reiterate that this is a bit of a paradox because water balance is not actually about balancing the amount of water in your body. It's about balancing the concentration of things like sodium. So we have these two different arms of the kidney. One reacts to concentration changes, and the other reacts to volume changes. And we've talked about how the concentration change side works, so now let's talk about the volume side. So let's say you have an increase in your extracellular volume. What is that volume made up of? Well, it's mostly made up of water. There's going to be a lot of solutes dissolved in that water, but those solutes don't actually take up volume. It's the water that's taking up the volume. So you might think that to decrease that extracellular volume, to bring yourself back to normal, maybe what you should do is excrete some water. But the problem is, if you think about it, that's going to have a result which is that it's going to increase the concentration of sodium. And so now we're going to activate the first arm that we already talked about, which is going to say, well, look, I've increased sodium concentration, so I better hang on to water and increase the amount of water in the body so that I can dilute that sodium and bring myself back to a normal sodium concentration. So in other words, you tried to excrete some water, but then this faster and more sensitive part of the kidney reacted to actually increase the amount of water back to where it was. So in other words, this mechanism does not work. So what does the kidney do instead? Well, instead of excreting water, what it actually needs to do is excrete sodium. Because if you excrete sodium, then what's going to happen to your sodium concentration? Well, it'll go down. And then as a result, the first arm of the kidney that we already talked about is going to get activated. It's going to try to increase the sodium concentration back to what it was, and the way it does that is to excrete water. So in other words, excreting sodium here allows us to excrete water. If we tried to excrete water directly, it wouldn't work because it would increase our sodium concentration. So let's recap here because this is getting really confusing. So we have these two arms of the kidney. The first one will react to an increase in sodium concentration by doing what? By increasing the amount of water in the body. And it'll react to a decrease in sodium concentration by doing what? By doing the opposite, by getting rid of some water so that the sodium concentration will increase. And now the second arm of the kidney is going to react to an increase in extracellular volume by doing what? By excreting sodium. And it's going to react to a decrease in extracellular volume by trying to hang on to as much sodium as possible so that you can then hang on to water without diluting your sodium concentration. So in a way, this is totally reversed. It's kind of the opposite of what you would expect. You would expect that to decrease sodium concentration, you would get rid of sodium, and to decrease volume, you would get rid of water. But it's actually the opposite. And the reason it's the opposite is that this first arm here of the kidney, this is the faster and the more important reaction that happens. Altering amounts of water is much faster and easier than altering amounts of salt. So the kidney is going to do that as quickly as it can to keep sodium concentration constant. Let's go through a couple of examples of what would happen if you changed amounts of salt or water in your body. So as a first example, let's say you eat an extremely salty meal. So the amount of salt in your extracellular fluid will go up. So what's going to be the response to that? It's going to be the usual response to a change in concentration. In order to bring the concentration back down, you're going to hold on to H2O. And you might drink some more water because you get thirsty. And so the result of that is that you are going to have an increase in volume. And now you have a normal sodium concentration but a greater volume, extracellular volume. So the other arm of the kidney is going to kick in and try to lower your volume by excreting sodium. And excreting sodium allows you to excrete H2O with it as well. And so this brings you back to normal. You gain sodium, which caused you to hold on to water, and then you got rid of that sodium and that water. Now what about if instead of eating a very salt-heavy meal, you drank a liter of water, let's say, or more. Let's say you drank 2 liters of water. So now you've increased the amount of water in your body, which immediately, just by dilution, is going to cause a decrease in sodium concentration. But that water also, transiently at least, is going to cause an increase in your extracellular volume. So now what's going to happen? We have actually both arms of the kidney are going to get activated here, right? Because one senses concentration changes, the other senses volume changes. But what's going to happen is that the one that senses concentration changes is going to act first, because we said that one is more sensitive and more rapid. So this is not going to stimulate anything yet, but the drop in concentration is going to cause you to excrete water so that you'll increase your sodium concentration back to normal. So that brings the sodium concentration back to normal. And at the same time, you've gotten rid of water, which is going to decrease your extracellular volume, which was increased to begin with. So actually it's going to bring your extracellular volume back to normal. So in this case, we see that if you drink a bunch of water, the result is very quickly you're just going to excrete that same water back and get back to the same original situation you were in. Now this correction, as we said, happens very quickly, whereas the correction here happened more slowly. So therefore, eating a bunch of salt actually ended up increasing your volume more than drinking water. This is sometimes why people might say that salt is volume. And one of the side effects of this is that eating salt will actually raise your blood pressure more than drinking water. And this is why people who have high blood pressure are told not to eat too much salt. They're not told to avoid water, because if they do drink some water, they'll very quickly get rid of it. But if they eat some salt, it's going to cause them to hang on to water, and it'll be slower to get rid of that salt in water. So now as one last example, instead of talking about just salt or just water, let's think about what happens when this person either drinks or gets an infusion of isotonic fluid. So isotonic fluid has the same concentration as your extracellular volume, so it's not going to change the concentration of the solutes, but what it will do is increase your extracellular volume. So therefore the concentration arm of the kidney is not activated, it's only the slower volume sensing arm, which in order to counteract this increase in volume is going to excrete salt and with it some water.